Hi everyone, in today's lesson we're going to talk about the trapezoid rule. It's another approximation method that we use to find the area under a curve. Now before I go through this method, I need to go through about what a trapezoid is. If I say the word trapezoid, I'm sure that a lot of you will draw something like such. This is actually an isosceles trapezoid where both sides or both legs are congruent. But the fact that makes it a trapezoid is that it has one pair of parallel sides, that this pair is parallel to this pair. But we could also draw a trapezoid like such, where it's not isosceles, where we still have one pair of parallel sides. This side is parallel to this side, but the other legs, these opposite sides here, are not congruent. So this is an example of a trapezoid. We even could also draw a trapezoid that is vertical. So we could draw one like this, where my pair of parallel sides is actually here. This side is parallel to this side. So these are three different ways that we could draw trapezoids. And the one that we're going to use today is actually going to be this one. And what it does, it's going to help us approximate the area under a curve. So we just need to refresh the formula for area of a trapezoid. So the area of the trapezoid is height times base 1 plus base 2 divided by 2. So take a minute, write this stuff down. This is the formula that we're going to need for today. So please make sure you have it on your paper before moving forward. Okay, so I wrote the area formula that we'll need on top of our paper. And the question is the same as what we've been working with. I've given you the function 2 over x over the interval from 1 to 7. But this time I want you to find the trapezoid approximation. So let's draw our sketch one last time. So there's my curve 2 to the x, and I want it over the interval from 1 to 7. And I need to first do the same thing as we've done before, is find the width. So remember, the width is the b minus the a over the n, where n is the number of subintervals. So in this particular problem, we're still speaking about 3. So 7 minus 1 is 6. 6 divided by 3 is 2. So each of these trapezoids, not rectangles, each of these trapezoids will have a width of 2. So let's calculate the area. So if each one of our trapezoids will have a width of 2, we could start from any end, it doesn't matter. Here's one width of one trapezoid. Here's another 2, and then one more. And that will give us our 3 subintervals. So what we're going to do is we're going to draw the trapezoid straight up here, straight up here. Here's my parallel sides, right? And this will be my trapezoid right here. So you see how it's closely approximating that curve? It's much closer than a rectangle will ever get. So here and here is our parallel sides, and then my trapezoid side will go up there. So I have a parallel side straight up, and then my trapezoid will connect there. So if you're looking at all 3 of these trapezoids, they're all kind of drawn the same way. They're all drawn straight, and then there's some curve here. So these are my 2 parallel sides. So this is base 1 and this is base 2. The bases are the parallel sides. And my height, we can call my width. The width here is the height. It's really because the trapezoid is kind of switched up a little bit or rotated up. If you had the trapezoid this way, it would be clear to see what your bases were. This would be base 1, this would be base 2, the parallel sides, and then this would be my height. So it is the same thing, except this is rotated this way. So my height now becomes this way, and those 2 are my bases. So if we're calculating the area of the first one, I'll use red for the red trapezoid. So the height we know is 2. and then base 1 plus base 2 divided by 2. So base 1's height and base 2's height. Well, base 1's height will be found by plugging 1 into your function. The height here is up there at 3, and this height that we'll need is at 5, and this other height we'll need is at 7. So go back to the y equals and put in 2 divided by x, and this time we want our heights to be at 1, 3, 5, and 7. So take a couple minutes, pause the video, get those values, and then hit resume when you're ready for the answers. Okay, so at 1 you should have a height of 2, at 3, 0.6 repeated, at 5, 0.4, at 7, 0.2857. So here my height is 2, my height is 0.6 repeated, my height is at 0.4, and the 7 is 0.2857. So for the red trapezoid, my height is 2 and 0.6 repeated. So 2 plus 0.6 repeated. Now we're going to add that to the trapezoid in blue. The height is 2. So we can go ahead and put the 2 as my height. And then my base 1 will be 0.6 and my base 2 will be 0.4. So 0.6 repeated plus 0.4 divided by 2. And then we're going to add to it my third trapezoid. So my base is still 2, or my height. And then my base 1 and base 2, so 0.4 is my height here, and 0.2857. So 0.4, whoops, not repeated. So 0.4 plus 0.2857. So take a minute, plug that into your calculator, and then hit resume when you're ready for the answer. All right, so you should be getting something similar to 4.4191. And if you want to round to the nearest thousandth, that's 3 decimal places. So 4.419 units squared. So that should be relatively close to the actual area. Take a look on the previous pages and see how it fares with respect to the left Riemann sum, right Riemann sum, and midpoint Riemann sum. All right, let's try example number 2. Okay, so same example as we've been doing. We have a square root of x, and I want to approximate using the interval from 0 to 1, and I want 2 subintervals. So subintervals means the 2 rectangles, but in this case, it'll be trapezoids. So step 1 is find the width. So the width will be b minus a over n. So 1 minus 0 over 2, 2 meaning the number of subintervals. So 1/2 will be the width. So again, we're at 0.5, and we're going to draw 2 trapezoids. So here is one trapezoid, and here will be the other, both with widths of 0.5. So here I'm going to go up to the curve, and I can draw a trapezoid like such. The reason why it looks like a triangle is because it really is. Because this curve starts at the origin, there's no height for you to go up. Therefore, this quote trapezoid is actually going to be a right triangle. So we can actually draw another trapezoid here and connect it from here to here and come down. So that looks more like a traditional trapezoid. So step 2, we're going to calculate the area. Now, if you want to use the trapezoid formula, you absolutely can. So I'll use blue for the blue one. So the height we know is 0.5, so we can go ahead and put that in. And base 1, technically there is no height, so this base 1 is actually 0. Plus the height here would be whatever the height is at 0.5. So you can go ahead and type that into your calculator and see, but since the function is just the square root of x, we can use the square root of 0.5. So we'll make this 0.5 square root divided by 2. Then we're going to add it to the green one. So the green one is 0.5 to 1, which is 0.5 is my height. So 0.5. And then the base 1 will be this height, which is, again, radical 0.5, plus something divided by 2. So the second height would be over here, which is 1. So when I do it in the calculator, the square root of 1 would actually just still be 1. So rad 0.5 plus 1 divided by 2. So you can go ahead and type that into the calculator and then hit resume when you're ready for the answer. Okay, so you should be getting an area approximately 1.3388. So if I round it to 3 decimal places, 1.339 units squared. Now, do me a favor, take a look, see how the left Riemann sum, the right Riemann sum went, and see if it's similar or close to this trapezoidal approximation. All right, if you have any questions, now's the time to jot them down. If not, we'll see you in class tomorrow. Have a good night.